Uh, Hi guys, so today we will be trying to solve this. This is a CMI 2022 question, question number 6. So basically, basically it says that basically we have a metric space. I mean, with the soup norm, basically we are given a norm linear space, right? Uh, with this soup norm, okay. So they are saying so basically they have defined a subset of this. So let me just reread uh, the subspace, sorry, subset. So basically, what is Y? Y contains all those functions from C01 to 01. Sorry, yeah, Y contains all those functions, real valued functions from such that basically the image of F lies inside 01, right? So the lies inside 01. Okay. So let me try to draw this. Suppose we have this. Right now, let's say it is this point is 0 comma 0, right? This point is 1 comma 0, and okay, so yeah, so this is 1 comma 1, this is uh, 0 comma 1. So now basically so they are saying basically all such functions. So suppose like this function, okay, this, yeah. So all these type of functions. Okay, so all this continuous function. Now they're saying that Y is compact, right? So I mean Y is not. I mean it's a metric space. So a metric space compactness we know means sequentially compact. So it's a if and only if. Now now basically we define this. This is a very common, right? Sequence of function x to the power n. Okay, so now limit. So now they are all continuous. Okay, so they belong to C01. Okay, and also I mean this all belongs to Y. Okay, so now if we take the limit, it will give us right 0. Okay, um, um, and this will be I think 1. Yeah, when x equals to 1. So now this function is not uniformly continuous, right? Sorry, it's not uniformly convergent because, right, these are all continuous. Okay. Now, if it is uniformly convergent, it should converge to a continuous function. Okay. But this is, let's say this is fx. So as you can see, fx has a discontinuity at 1. Okay. So this is not uniformly convergent. So basically, this does not converges in the soup norm. So it doesn't have any subsequence which converges in the soup norm. So basically, this is not right. Y is not compact. Okay. So Y is not compact. So Y is not compact. Um, okay. So now so Y is compact. This is false. Now X and Y are connected. We know X is connected. X is path connected, right? So because right. Let us talk about now. They are saying that X and Y are connected. Okay. X. I mean, let's just take this function. Right. This belongs to X. This is a continuous function from C01 to R. So okay. So X is path connected. So X, which is path connected. Okay. For all F comma G belongs to X. Hmm. Oh, I'm sorry. This should be T. All right. So yeah. So basically, we have a path between F and G, and everything. Basically, it's a convex. It's a convex set. So it's path connected. Okay. Now, what about Y? Right. What about Y? Y contains all such functions whose image lies inside 0, 1. All right. Now, so take fx comma gx belongs to Y. Okay. Now, once again, we define gamma t. So this is gamma t 1 minus t f of x plus t g of x. Okay. So now if we take the like for any t, right? So if we take suppose, so let's just say suppose, so basically let's say we take the norm. Okay, so we take the norm. Uh, uh, yeah. So basically we take the norm. Yeah. So now, so basically, right. So this would be nothing but supremum x belongs to 0, 1. Okay. Sorry. This would be mod 1 minus t f x. Okay. Instead of this, let me just write. mm so basically this. So this is less than equals to mm, norm of 1 minus t f of x plus norm of t g of x. Okay, so this is nothing but, yeah, now tg minus x, which is nothing but 1 minus t mod 1 minus t sup x belongs to 0, 1 f of x plus t sup x belongs to 0, 1 g of x, right? Mod of g of x. Okay, so now this, since fx and gx belongs to c, belongs to y, it's sup. So since fx and gx belongs to y, its sup is less than equals to 1, right? So basically this will be less than equals to 1 minus t plus t to 1 into 1. So which is nothing but 1. So so this gamma t, uh, so this gamma t lies inside um, y for all t belongs to 0. Okay, so y is path connected. So y is path connected. So our this option is true. Our option B is true. Now they are talking about Z. Now what is Z? I haven't actually read Z. So let me just read it first. So basically Z is nothing but all those functions such that f01 f01 is like the image of f, I mean f of 01, I mean image of f lies between 0 to half and half to 1. Now since it is continuous, like by intermediate value property, like it cannot contain, like, so basically, like let's say if you have this, okay, so this is 1 comma 1, so basically this is 1, this is 1, so, and let's say this is half, okay, so it cannot have functions like this because, I mean, of course, it's continuous and by intermediate. So basically, it will have functions like this or like this. Okay. Okay. I mean, in either part of, like, it will be divided into two parts. Okay. I mean, it will have two components. So yeah. So okay, our second option is Z is path connected. Okay, we'll see uh, that. I mean, we can see it's clearly not, but we will prove it. So yeah. So so what about Z? Okay. So let me see. Option C. So basically Z is all those f belongs to x such that image of f, mhm, image of f is nothing but is contained in 0, half, union, half and 1. I mean open half, closed one. Okay. So yeah. So now when I was actually doing this sum, so okay, first let me just draw this. So when I was doing this sum, so I was thinking like how to, construct a function such that, okay, like which uses this same principle, how to get a, I mean, sequence of functions which is not uniformly convergent, right? So yeah, so that we can show that it's not compact. So basically, so I thought, okay, maybe if I take a point, let's say 2 by 3, since half is not included, and this is 1 comma 1. So if I join this, right? So if like can I make functions like this? So basically first let's start with a line from 2 by 3 to 1 comma 1. So like I took fn x to be I mean okay, x to the power n by 3 plus 2 by 3. Okay, so right. So as you can see that fn of 1 is 1, okay, and fn of 0 is 2 by 3. So it's all starts from 2 by 3 and goes to 1, 1 comma 1. I mean 1. So now now clearly limit n tends to infinity, fn x is which let's say it is fx. So it is of course pointwise convergence. So this is 2 by 3. Okay. So this is 2 by 3. So when x is less than half, sorry, sorry, I'm sorry, I'm so sorry. When x is 2 by 3, oh, okay, sorry. This is 0, I'm so sorry. This is 0 and this is 1 and 1 and yeah, and 1 when x equals to 1. So as you can see, this is not so uniformly convergent because each is continuous. If each fn is continuous, if it converges, if it is a uniformly convergent, then f should be continuous. It is not. F is not continuous, not continuous. So fn x does not uniformly converge to f, right? Okay. So there is no subsequence. I mean, there is no basically uh there is no subsequence which converges, not compact, sequentially compact. So this is not compact. Okay. So this is true. Okay. Now Z is path connected for the path connected part. So as we know that norm function is a continuous function. We know that norm is continuous. So basically we can like define, let's say we define a map. Uh, okay. So let's say it's from C01 to R. So basically phi of f, right? This is norm of f, which is nothing but sup x belongs to 0, 1 f of x. Okay. Now, as we can clearly see that phi of z is 0 to half and half to 1. Now, this is a continuous function. Phi is continuous. Now, like phi is continuous. So, and okay. So, now if z is connected, then its image will also be connected. But this is not connected in R. So, Z is not connected. So Z is not connected. Okay, so yeah, so it's not path connected. So option B and C. Okay, and one more thing that I wanna show you guys is that like I took this function fn of x, right? So I took this function fn of x, it will look something like this. So okay, let me actually switch to a different scene. Yeah, so it will look something like this. Right, so if I vary n, so it will, as you can see, as n goes to 100, so as n will tend to infinity, so basically it will be 2 by 3. So yeah, it will be 2 by 3 as n tends to infinity at x equals to 0, and right, and at x equals to 1, you see a jump discontinuity. So yeah, at x equals to 1, it will be 1, and this is half. Yeah, so okay, so yeah, so the graph will look something like this. I mean, the sequence of functions will look something like this.